Hello everybody, my name is Walter and this is episode 77 of my Redstone Commands Series. In this episode I want to cover briefly the game test framework and the test command. But what is this all about? Well, Minecraft nowadays contains an automated end-to-end testing framework, which means you can define tests and then run them somewhat automatically or via the test command and check whether the latest Minecraft update or the mod you're currently working on broke something or behaves as it's supposed to. Now, this has apparently been in the game for quite a while, since 1.15, but has been hidden away, so only the developers actually had access to this, and with 1.21.5, this became available to all of us. Now, each of those tests you can define has certain components. For one, you have a so-called test instance. This is a .json file in a data pack, in the data namespace and then test instance subfolders, and that defines basically the singular test. Then we have a so-called test environment, which is responsible for the circumstances of the testing, weather, time, game rule, and so on. We will go into the details in a bit. And those are also .json files, but in the data namespace and then test environment subfolder of a data pack. Then, potentially, you also have a so-called test function. So this is not a .mc function file you have in your data pack. This is actually a true game function somewhere in the source pack or in your mod that you want to test. And subsequently, there are two different types of tests, as you can see later on. Function tests, where this plays a role, and block-based tests. And then finally, we have, for every test, a test structure. This is a .nbt file you can either find in the world safe itself under generated namespace and then structures, or in a data pack under data, namespace, and then structure. This is, as the name implies, just a structure like you would get it from a normal structure block that stores parts of your text that are more physical than just code. And in those structures, then you can use the test blocks, which are available under the operator utilities in the creative menu or inventory. And depending on which blocks in the end get powered first, the test either passes or fails. That's the general idea. We will see a few examples later on. And then finally, we have the command test, which is used to more or less automatically trigger and work with those test instances. And now let's first have a look at the definition of test instances. So this is, as I said, a JSON file, so it follows JSON syntax. So we have a big compound with some information about the test itself. The first thing you should define in there is the type of test you're running. So is it a function test or a block-based test? If it's a function test, then later on you will also have to define which function you want to test. As I said, and as far as I understand it, this is a game function, so something in the source code, and not a .mc function file somewhere in the data pack. Referenced, though, is it as usual, so namespace and then ID as it's registered in the game. If it's a block-based test, then all of the relevant stuff happens in the structure, so you don't need a function. Now, once you have the type, you should define the environment. And here you can either reference a .json file in the test environment via namespace environment name, or you can directly define it in here again as a compound. Then we have a structure. This is the testing structure that gets loaded in at the start of the test and then does stuff, and depending on which blocks get powered or not, the whole test passes or fails then. So as I said, this is a .nbt file somewhere in either the save game or the data pack, and reference here, as usual, namespace and then the name of the structure. Next up, max ticks. This is the timeout limit for our test. So if the test runs and runs and runs and doesn't really get a fail or pass condition, then once this number of ticks has been reached, it times out. This is rather important if your test has the potential to catastrophically fail and never get either a pass or a fail otherwise. Default or minimum here is obviously 1 tick, but it can or should be longer if you need more time. Function I already talked about. Rotation allows you to rotate the structure before it's placed in 90-degree increments. We have 4 options here. So none, which is the default value, clockwise 90 degrees, 180 degrees, or counterclockwise 90 degrees. And then setup ticks is a waiting time between the test setup, so loading in of the structure and setting of the various conditions, environments, and such, and the actual start of the test. This is per default set to 0, but if, for example, you have some entities in there and those need to fall to the ground first before you start your test, then you would want this a bit higher than 0. The next three are Boolean. So required, which is per default set to true, means that this is a required test and not an optional test, which has some relevance for some of the reportings and also for some of the commands. Then manual only, per default set to false. If this is set to true, this means this test is not part of automated test runs. This can only be triggered by the player manually. Then we have sky access. For this to understand, a quick rundown. When a test is run, during the run of the test, the entire structure is encapsulated in a layer of barrier blocks. And if this here is set to true instead the default false, then the top of that box is left open. That's the only difference about this. The last two belong together a bit. Max attempts is the number of test repetitions you allow until you declare the test failed. Per default, this is set to 1, but if your test is somewhat probabilistic and you want to make sure it's not a fluke, then you can set this to a higher number. Required success is more or less its counterpart, so this is the number of pass attempts you require before you declare the test actually passed. Per default, this is set to 1. So if this is 1 and 1, then the test has to pass in the first run. But if you, for example, have a test that is somewhat probabilistic, you might want to set this to maybe 100 tests, and from those, you want 90 to succeed. Now, just a few examples. So this here is a test that is in the vanilla Minecraft. And as you can see, it's a function test that, as the name implies, always passes. This is just an example for modders and such that they have something to work off. On the other hand, this here is a test I'm using for my episode here. And yeah, you can see I'm using my own environment. I have a test structure for that, setting a few things. And well, this here actually is a test that is probabilistic. It will only pass in 50% of the time. So I have a second variation of this that actually checks whether it has passed at least 10% of the time. And you can see that is how you can play around with the max attempts and the required successes. And with that, it's time to talk about the test environments. Now, these again follow the JSON syntax since they are either part of the test environment definition or their own JSON file. There are several types of environments, so let's go through them one by one. The first type is all off, or if you write it fully, Minecraft double point all off. It works without the Minecraft as well. This is an environment that actually summarizes or applies multiple different, potentially, environments at the same time. So this can be used if you need different types of environments at the same time for your test. And yeah, you have type, all off, and then you have definitions, which is a list of, well, it can be empty actually if you don't want to imply any environment and your test instance does need a test environment at least. Or you can add 1, 2, or even more environments at the same time, basically. And each of those are either referenced as namespace environment or directly defined in there as a compound again. Second type is type function, and this references now again back to point MC function files. So with this here, you can execute Minecraft functions at the start and or the end of a test. So setup, so these here are both optional. Setup is the function, referenced namespace function name, that is run at the setup of the test, so directly before the test starts. And the tear down is the opposite, so once the test has run through, passed or failed, then the tear down function is executed. This again is referenced via namespace function name. Next up, we have environment type game rules. This allows you to set game rules during the run. They will be reset after the game run to their default value, not to what they were before, but to the default value. Very important difference there. So type game rules, and then you have a list called game rules list, and that can contain then compounds, each with a rule, which is then just the name of the game rule, like do weather cycle or do day-night cycle, and then the value, which is either true or false. Some other rules require numerical values. Those are the int rules. Again, just a list with compounds, rule name like max command chain length, and then value, which would be maybe 64,000 or something like that. So that allows you to set game rules during the test run. Then we have the option to set the weather or the time of day. Both work pretty much the same way. So type weather, then you have the weather, and this then can be either clear, rain, or thunder. And time of day requires an actual number, which is just the time of day in ticks. So 18,000 would be, for example, midnight. Yeah, with that, let's have a look at an example or a few of them. So this here is the default environment for the always pass test from before. So you can see all off and the list is empty, so it doesn't really change anything in the game as it is in the moment. And this here would be my example I'm using here. So here I actually went with an all off that contains all of the other types of environments. So I'm setting various things like a function to be done during setup and tear down. We'll have a look at those in a second. I'm setting some game rules. I'm also setting the weather and the time of day. And here, this is the function that is called during setup. So basically just setting up a scoreboard objective and then setting it to a random value between 0 and 99. And the teardown function clears the objective again and also sets weather and time to my personal favorites. I did that, although in the wiki it says that this here reset weather and time to what it was before. I didn't encounter that. For me, it was just left where it was during the test run then. So I added that to my function file. So that might be also a reason why you might want to have an environment function in there. And with that, we finally get to the test blocks and also the test instance block, which are actually different blocks. Now, the test blocks are actually one block with 4 different modes, similar to the structure block, which do slightly different things and which are used in the structure of a game test during the test run. We have a test block start, which creates a redstone signal when the test is running. We have a log block, which logs a message into the log file. We have a fail block, which when powered first, fails the test. And we have an accept block, which when powered first, passes the test. The test instance block is a special case. This is a completely different block actually, and allows you to interact with the test instance itself in certain ways, and also serves as a beacon that tells you whether the test is currently running, has passed, is a required test and failed, or is an optional test and failed, depending on the color. And the interactions here primarily have to do with the structure itself, so you can use this to adjust the structure, to save the structure, to increase or decrease the size of the structure, but also things like resetting the test, loading in the structure, and running the test. One little caveat here. If the structure is saved in a data pack and not your save game, if you try to save using this user interface there, it will recreate it in the save game and not override what you have in your data pack. Just a little caveat there. So let me just quickly show you those various blocks. So this here would be the test instance block. So this here is the test instance block for our always pass test. So the default vanilla Minecraft test. Here you can see this is the name, and then you have additional information. So the test is a function test. Its function that is being tested is always pass. We have an empty structure. Actually, this is an actual structure called empty point NBT. And then the batch, this is a known error. This is actually the environment, Minecraft default. Here you have the sizes. You can rotate it if you want it. You can reset and load. You can save the structure. And then you can also load and run it. And then you get this beacon here, as you can see. Well, let's just reset this. And in the chat, as you can see, you get also some information about the test run itself. This over here is one of my 2 tests. In this case, my test. It's a block-based test. I have a structure, my test structure, and I'm also using my own environment. Size is 5 by 5 by 5. And I can now also run this. You can see it got dark for a moment, and then the test passed. In this case here. So how does this work? Well, this here is our start block. This here is the log block. And this here, depending on the smiley, is the pass and the fail block. And all I am doing here is basically this here, as you can see, produces when the test has started, a redstone signal, which triggers, first of all, this command block here. And that just checks whether my random variable is 50 or higher. So 50% of the time that is the case. And it also powers the log block. Over here, I have a little bit of circuitry, which, depending on whether this test here passed or not, this signal here is then sent either to the pass or to the fail. And that is the entire test structure. So let's just run this again. And this time it failed. And since this is an optional test, according to the definition, this here is orange. And you can see all required tests passed, just optional test failed. And you can also see the barrier box, the box around it, which only disappears if the test is either removed or reloaded or something like that, or as long as it is failed, you can see the structure remains encapsulated, although at the top we have our sky axis according to the definition. And now let's just reset this, and then all of this here has disappeared again. And with that, it's time to talk about the test command and its syntax. Now, this is a very versatile command with lots of different options, but many of them are very similar to each other, so I'm not going to show you every single option in this command here. Independent of what you want to do, you always start as usual with the name of the command, in this case, test. And then it deviates. Now, the first thing you might want to do is just run a test, which includes placing a test instance block, loading the structure, running the test, and seeing what the result is. And all of that can be done with just one command. And this is the test run command. So test, run, and then you define which test you want to run. After that, you can add more optional arguments. So the first is how many times do you want to run this test in succession? So do you want to just run this once, or maybe 10 times, and then see in the chat history how many times it passed, how many times it failed, or something like that. You can tell it to stop the moment the test failed. You can also, again, add some rotation to the test structure here. So you basically add here a number between 0 and 3 including, and that is just multiplied with 90 degrees, and that is the new rotation. According to the wiki, you can add any integer here, but it does only work without an error with those 4 numbers here. And then you can also define tests per row. So how many tests do you want in a row when you have multiple tests running in parallel? And then they are basically ordered in a rectangular grid, and this is just how long those rows are. Although, to be totally honest, I'm not sure why it's in the run command an option and not in the run multiple option, because here it would make definitely more sense. But maybe they will change that in the future. So that is how you can run a single test, or a single test even multiple times in succession or in sequence. If you want to run the same test multiple times at the same time, so in parallel, maybe you have a client-server structure and you want to check if your clients work when you have 100 clients at the same time, then that is the way to go here. So test, then run multiple. Again, that has test name. And then how many parallel instances do you want to place? This is per default set to 1, but you can set it to a higher number, and then those are set in rows of 8 at the max, and then a rectangular grid with that. As I said, I think this here is just accidentally set or put to the run command and should actually be part of the run multiple, but maybe I'm wrong with that. Then, somewhat similar still, we have the test verify command. So test verify and then the name of the test. And this, according to the wiki, verifies the test. That's all the wiki tells you. Now, I did just run this, and it looks like it just puts down a 10 by 10 grid of the tests and just runs them in parallel. So basically a quick version of a run multiple. But the wiki is rather sparse on details according or in response to all of the test commands, unfortunately. So then you have the option to just retest tests that failed their last run. So test and then run failed, and then we have two options. We can either stop there, or we can continue with how many times until failed, rotation steps, and tests per row. So the same we had with just run. Or we can run failed and then only the required tests. So all option tests are not added to this, and then again, number of times. Next, we have the option to rerun tests in certain areas. So test and then run closest reruns the closest test to you if there is one within 15-meter radius. Run that reruns the test you're currently looking at. This is very useful since you don't have to fiddle around with any coordinates. And run these runs all the tests within 200 meters radius. Once you have either of those three, you can further define whether you want to run them multiple times and whether you want to stop if they fail. So somewhat similar to before. You can also use test and stop to stop any tests that are running at the moment cold. They just stop. You can also reset tests, so they are basically prepared for a new run with either test reset closest, so closest within 50 meters, reset that, the one you're looking at, or reset these, so within 200 meter radius. You can also clear tests, which includes removing the structure, removing the test instance block, and then also placing a stone foundation below the space where the structure was. The foundation is 2 blocks high and goes a bit further in any direction than the test structure footprint was. So that can play even more havoc on the surroundings than just placing a structure in the first place. So fair warning, don't do this in a place you don't want to lose the blocks around it. Anyway, you can test clear all. That clears all the tests within a certain radius, which per default is set to 200, but you can change that, obviously. Clear that clears the one you're looking at, and clear these clears all within 200 meters, so basically clear all with the default radius. So here you have a bit of an overlap. Then, somewhat similar to the datapack create command, you can also test create a test with a new ID. This ID must not be in use yet, or you will get an error. And then you can option define the width and then height and depth of this structure. Default width is 5 and height and depth, if not defined, are the same as width, so it's a cube. Fair warning here, this only places the test instance block and prepares a default, somewhat pre-filled structure. It does not create any point NBT file for the structure, and it does not create any point JSON file for the test instance. Those you will still have to create yourself. Test, locate, and then the name of the test is supposed to tell you where a test of that given name can be found. I couldn't get it to work. Maybe I'm doing something wrong, but I couldn't actually use this. I loaded in the test, used the locate command, and I just got the message couldn't be found. So, yeah. And then finally, we have test pos, and then potentially a string, basically a variable name. This allows you to get the local coordinates of a block within a structure, within the test structure. This can be quite useful when you're working with a function environment and you need to place specific blocks in a specific point. So that can be quite useful there. The var is just basically a string that gets inserted into the part you can copy to your clipboard via the click event in the chat message. And then this is the last option and one I couldn't test for myself, pun intended. Test export. This is only available in the IDE environment. So when you're really programming in the source code or in your mod or whatever, and that is supposed to export tests. Yeah, so you can either export a specific test or you can export the closest, the one you're looking at, or all within 200 meters. But as I said, I couldn't test this because I am not working in the IDE environment. I'm just playing the game. Yeah, with that, we come to the last point concerning automated testing. It's possible to directly, with a single command line, I'm not talking about Minecraft commands, I'm talking about Windows command line commands, with a single command to start a server, run all required game tests or all automatic tests, and then exit via the command line and get back the information of how many have failed and similar. But I'm not going to go further in the details here. If you're interested in that part, you might want to have a look at the wiki. That is somewhat more in detail explained there. And with that, we've reached the end of this episode about game tests. I hope you enjoyed it. I wish you a nice day, and well, see ya.